what is stem and leaf plot. So it's an alternative to the histogram. It looks something similar to what histogram, but it's different, and but histogram and leaf plot can be used for similar purpose. The stem and leaf plot gives the visual representation of data without losing the individual data points. So in the y-axis we have got frequency, and in the x-axis we have got the range in which the numbers, the actual data points, fall into, right? Whereas in the stem and leaf plot, you actually do not lose the individual data points. Like in this case, the individual data points are represented on the plot. So this particular this particular number is nothing but 5, and this particular number are nothing but 16 and 17. Okay, 16 and 17, 5, and then 16, and then 17, and then 28, 23, 26. Right? So that's the way we can get back to the original number series. Now how do we construct this series again into leaf, stem and leaf? We'll just learn in the next slide. So how do we create this stem and leaf plot? Well, let's take an example here. So I've got a number series, and the first thing to do is that to sort it in ascending order, right? So the number series is from 12, 14, and that another 14, 20, 26, 31, 56, and 59. Now this series we want to represent on the stem and leaf plot. So how do we do that? So first notice what is in the leftmost side of the number, or like in this case the decimal number. It's 1. Again here it's also 1, 1, 2, 2 and 3, 5 and 5, right? So this is the decimal number. So what we will do is that we'll take the extreme number, or the first digit of the number, and we call it a stem, and it starts with 1 and ends at 5. So in between we have got the 4 is missing, so we have 1, and then we have 2, 3, there is no 4, and then we have 5. So we what you do is that we put these numbers right, and we calling it as stem. So we put 1, 2, 3, 4 and 5. Remember that we do not have 4, but still we need to put 4. We cannot have a gap, so we need to put 4 over there. Then against 1, how many numbers are there? Well, in 12 you have got 1 and 2, then 1, then in the leaf portion I put 2. Okay, and then the next number is 14. So what I do is that right next to that I put 4. That's how we understand. So 1, 2, first number, and then 1, 4. Then we have got another 14, so that is again 1, 4. And the next one is 20. So we go to the one step below, and then against 2 we got this 0, right? So we'll put 6 over here. Yeah, I just missed that. Okay, so we have 20, and then we have 26. Similarly, in the 30s we have got 31, right? So against 3 we put 1, and there is no number within 20 to 30, so we go one step below, and then against 4 there is no number, right? So we just leave it blank. And then in 50s we have got 56 and 59, so we put 6 and 9. And now this is how the leaf plot look like. We do not lose the actual data points, right? So it similar to histogram, but it gives additional advantage that you can actually look at or get back to your actual data series from the stem and leaf plot. So where is it used? Actually this is used is to show the relative density and shape of the data, right? And then you can also find the outliers in your data set by looking at the stem and leaf plot.